Hi, for the Pascal's triangle and binomial theorem. So the Pascal's triangle and binomial theorem are actually two ways of expanding binomial. So binomial expansion. So for example, if we would like to expand um x minus 3 raised to 4, so we can use the Pascal's triangle. By the way, this example is the one in the learning activity form that I provided in the LMS. So the first is Pascal's triangle. Triangle. And then the other one is the binomial theorem. In the first one, the Pascal's triangle. So what we need here is we need to create our own triangle. So how? So you start with 3 ones. So which will form a triangle. So 3 ones. So 1 at the top, okay, followed by 2 ones, like that. So you do have a triangle. Next, you can actually what? You can actually add this 2 ones here. So 1 plus 1 would become 2. After you add, do not forget to include 2 ones again. So 1 on each side. Next, you add the numbers. So 1 plus 2. So we do have 3. 2 plus 1, we also have 3 again. Okay? So you put 1 on both sides. Then you add the numbers. So 1 plus 3. So you add the numbers by 2. Okay? So just 2 at a time. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then do not forget the 1 on each side. Next, you add again. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So put 1 on each side again. What else? So we can actually continue this. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Then 1 again on both sides. You can actually continue the pattern. All right? So well, as many as you can if you want. All right? So because the given is x minus 3 raised to 4. So this is the given, x minus 3. So what you need to do is you need to take a look at the exponent of the binomial, which you are going to expand. So the exponent is 4. All right? So this 4, when you add 1, you would be able to know the number of terms that you're gonna have, both for your solution and your final answer. So it means that you're gonna have 5 terms. And then the purpose also of this exponent, 4, so other than adding 1 for the number of terms, you can also what? You can also look for 4 in the Pascal's triangle, in which 4 is the second to the last in the row. So second to the last number is 4 in this row. All right? So it means you're gonna need um this row that contains 1, 4, 6, 4, 1. So these numbers will actually serve as the what? As the coefficient of your expansion. Actually, your solution. All right? So we do have here equals. Okay? So we're just gonna copy the coefficients 1, then 4. So don't forget to put plus. The 6, so that is plus 6, plus 4, then plus 1, like that. Then after, you need to copy the first term in the given binomial. So the first term is x. So this first term, you're going to copy it all throughout the terms. Like that. So after you copy, you're gonna put exponent. So if you read the learning activity form, the exponent of the first term will actually be what? The given. So you start with a given, which is raised to 4, and then it will be decreasing. So we do have 3, 2, 1, 0. Okay? Next, you are going to copy the what? Second term, which is -3. Why is it -3? Because the given is x minus 3. So automatically, the second term will actually become negative because of the minus. All right? If this is plus 3, then it is just positive 3. But then since this is x minus 3, automatic 3 is negative. So you're gonna copy the sign. So we do have -3. Do not forget to enclose in parentheses the -3. Because it means that if it is together with this x here in our solution and and with the coefficient 1, it means the operation is multiplication. So do not forget the parentheses. So -3, -3, -3, and then -3. For the exponent of the second term, -3, if x started with the highest exponent, which is 4, which is the given, so the second term, -3, will actually start with the lowest, which is 0. Then the rest, so it is already increasing. Okay, until you're gonna have 4 on the last. Next, so you continue the solution. Okay, so all variables with the exponent of 0, automatically, this will become 1. Okay, then just simplify. So how are you going to simplify it? You start first with the what? So you start with this. So we do have 1 times x to the fourth is x to the fourth times 1. So still x to the fourth plus 4. We do have your x cubed. So -3 raised to 1 is -3. Isn't it? Then we do have 6 x squared. -3 raised to 2. So -3 times -3 is positive 9. Plus 4, x raised to 1 is x, -3 cubed. So that is -3 times -3 times -3. So that is -27. Then we do have plus, -3 raised to 4 is positive 81. Remember, any number you raise to even would be positive, and any number you raise to odd would be negative. All right. So continuing, so we do have x raised to 4. Next, as what you can see, we do have um we do have the 4 and the -3 here. Okay, actually you can multiply this as well as the 6 and the 9. So because these are numbers on the same term, then the operation is multiplication. So you just simplify it. All right. So we do have 4 times -3 is -12. Then we do have x cubed plus 6 times 9 is 54. We do have x squared. 4 times -27 is -108. Copy the x plus 81. This is the final answer. So that is using Pascal's. What if it is already binomial? Okay. So in the binomial, what is important here is you know about this one in parentheses. So this is actually combination. Combination, this is actually in statistics. combination. So we do have here the N and the R. So this combination, you actually do have this in your calcu, the NCR. So you just look for it in your calculator. So let us expand the given. So with the given x minus 3 raised to 4. So x minus 3 raised to 4. Okay. So as what you can notice, we do have the exponent of 4 again. All right? So you add 1, you're going to have the total number of terms. So it means we're going to have 5 terms. And then this 4, okay, you're going to write this combination 4 times. Okay? 4 times plus 1. So that is actually 5 times. So we do have here equal. So let us put the parenthesis. That is a combination. So 1. So again, 5 times. 2. 3. 4. So I'll just make the space a little small. So 1, 2, 3, 4, 5. Okay? Next. So as what you can notice, the exponent is 4. Okay, 4. So that will be the value of the n. And that n of 4, you're going to write it all throughout on all terms like this. Okay? And then the r. So for the r, you're going to start with 0. So which is actually the lowest. So 0, then increasing 1, 2, 3, 4. You will notice that on the last, so the n and the r are the same. So we do have 4 and 4 here. Okay, next. So we're gonna do the same with the Pascal's triangle a while ago for the first term and the second term. So we're just gonna copy the first term. So the first term is x. So x. So just the same as the Pascal's a while ago. Then the exponent of x will be what? So the given, which is 4, then decreasing, like that. And then you copy the second term, which is negative 3. So we do have negative 3. Do not forget to put in open and close parentheses. Like that. And then the exponent of negative 3, you start with the lowest, which is 0. Then, of course, increasing. Okay, next. So what are you going to do with this in parentheses, which is the combination? So like the 4 and 0, okay, this one, which is combination. In your calcu, you can input this as 4. Then you click on the C. Usually the NCR key or button is on the division of the calcu. But then you need to check your calcu because we do have different brands and models of calcu. So you just try to check. So if it requires you to combine or to have a combination of keys with the shift. So shift and then division symbol. So that's what you need to do. But then again, take a look at your calcu because possible the combination would be different. The combination of keys. So here, the 0 here is 4C0. Okay? In which it will give you a value of 1. So using your calculator. So 4C0 equal sign. So the answer would be 1. Okay? For C1, the answer would be 4. For C2 is 6. For C3 is 4. And then for C4 is again 1. All right? And then, so with the first and second term, the x and the negative 3, so you take a look at those that are raised in, well, raised to 0, so automatically it will become 1. All right? So copying, we do have here x to the fourth, so times 1, so that is x to the fourth. We do have here x cubed, negative 3 raised to 1 is negative 3. We do have here x squared, negative 3 raised to 2 is 9. We do have here x raised to 1, so simply x. Negative 3 cubed is negative 27. And then x raised to 0 is 1. Negative 3 raised to 4 is positive 81. Okay? And then again, you can multiply the number here. Okay? The 4 and negative 3. So this 4 and negative 3, the 6 and 9, the 4 and negative 27. So you're gonna have the simplified. So x to the fourth. 4 times negative 3 is negative 12, x cubed, plus 6 times 9 is 54, x squared. 4 times negative 27 is negative 108, x, plus 81. So as what you can notice, the answer in the binomial theorem is the same with the Pascal's triangle. All right? So somehow there is a similarity with the solution. The only difference is from where the coefficients are from. So in the Pascal's triangle, the coefficients are from the triangle. And in the binomial theorem, the coefficients are from the combination, the NCR, which you can actually compute using your calculator. All right? So that's it. Thank you.